Okay, welcome to page 4. I have not done page 4 yet, and like I said, these can be kind of tough. These are the identities, simplifying these things on each side. So because I've never done these before, I might not take the shortest route, and because there are many ways to do this, your route might be different. Let's just find out where all this takes us. So first, let's try to, so I'm looking at this. I don't see anything squared, so I can't use difference of squares. I can't use the Pythagorean identities. So what I'm going to do instead, and there's not really a lot of, I guess I could multiply both sides by secant if I wanted to get rid of the denominator, so that's an option, multiplying both sides by secant. Or I can get everything in terms of cosine and sine. And I think that's what I'm going to do. So this side, 1 over secant, is going to be cosine of x. Secant over here, let's come back to that secant for a second, and let's get tangent. Tangent is sine x over cosine x, and this is times a sine x. And then secant's just 1 over cosine of x. Okay, so now what we can do is we can say we can equals. We can bring these two together, sine x. So sine times sine x is sine squared x over cosine of x equals cosine x. And then I can combine this fraction. They already have common denominators, so that makes it nice. 1 minus sine squared x over cosine x is equal to cosine x. And now you have a couple of options. You can multiply both sides by cosine x. That would give us cosine squared over here. 1 minus sine squared equals cosine squared. That's a Pythagorean identity. You're done. That's one option. Another option could be 1 minus sine squared x is equal to cosine squared. So you could say that this is cosine squared x divided by cosine x is equal to cosine x. And then this cosine right here on the bottom would cancel out that cosine there, leaving just cosine x to cosine x, and we're done. But if you decided, so an alternate way you can do this is if you multiply both sides by cosine x, you would get 1 minus sine squared x equals cosine squared x, which also is correct. There's a lot of ways to go about these. If you can get both sides to be the same, you're done. If you can get something to be a Pythagorean identity, you're done. Doesn't matter which way you choose. Okay, this guy over here. 1 plus cosine x over sine x is cosecant x plus cotangent x. I think what I'm going to do here, I think what I'm going to try first is I'm going to try and get rid of this denominator. So I'm going to multiply both sides by sine x. Let's see what happens if I do that. Hopefully it doesn't become an abomination. So this cancels out over here. And we get 1 plus cosine x is equal to, I think what else I'm going to do, I'm going to do 2 steps at the same time. I'm going to multiply both of these both sides. But I'm also going to change these to sine and cosine. So cosecant is 1 over sine x plus cotangent. Cotangent is cosine x over sine x. And this is sine x over here. We're bringing that down from the top. So now what I would do is I would distribute sine x into here. So we're going to distribute sine x into both these spots. I'm going to write this out for everyone. I mean, you don't have to write out every step here, but I'm going to do it. Sine x times 1 is just sine x. And then sine x is going to be multiplied to the next one as well. So that's going to be over sine x plus, I still have a cosine x on top and a sine x on bottom. So I just distribute this to that fraction and to that fraction. These have the same denominator. We could combine them, but we could, I think I'm going to leave them separate because sine x cancels out sine x here, and sine x cancels out sine x here. So that leaves us with sine x divided by sine x is 1. And then this canceled out, so that leaves us with cosine x on this side, which is exactly what we have over here. And so we are done. We are done. Okay, this one. This one looks like, this one looks rough. Let's see what we can do with it. I'm going to work with just the left-hand side right now. The right-hand side seems pretty simple, sine squared. So I'm just going to work with the left-hand side. Maybe. So there's two ways to approach this, and I'm not sure which one will be fastest. New plan. I'm going to get rid of this denominator. Denominators are annoying. Denominators are especially annoying when they have addition and subtraction in it. So I'm going to get rid of that. I'm going to multiply both sides by tangent x plus cotangent x. That way, that cancels out that. And this is going to be tangent x plus cotangent x. Hopefully that'll be the best way. We'll find out. Denominators are the worst. Denominators are just, addition and subtraction in the denominators are worse. So once I do that, I'm going to make everything in terms of sine and cosine. So secant is 1 over cosine x times sine x and this is going to be equal to sine squared x times tangent is going to be sine x over cosine x, and cotangent is going to be cosine x over sine x. So let's fix this over here. This side over here is going to be sine x over cosine x, which will be tangent, but we'll leave it like that for just a second. And let's distribute this. We get sine, so sine times sine is sine to the third x over cosine x. And then we are going to do sine squared x. So we distribute this to the next fraction times cosine x over sine x. Okay. So what happens here is that, let's simplify some stuff here. That cross, so 1 sine x will cancel out 1 sine x up here, leaving sine times cosine. And then we're going to get these to have so this no longer has a denominator. So we're going to get these to be common denominators by multiplying by cosine x over cosine x. That way, this fraction here has a common denominator with this fraction over here. So that would give us sine x over cosine x is equal to sine to the third x plus man, this is going to be weird. Sine x times cosine squared x all over cosine x. Great. Cosine x is going to cancel out cosine x and multiply both sides by cosine x. And then, if I look at these two terms, I have a sine in this term and a sine in that term. So let's factor out a sine. So sine x is left over here is equal to, so if I factor out one sine, factoring out a sine, that means that leaves me with sine squared here, because I'm just factoring one of those out. So I lose 1, 3 becomes 2. And I lose this one. I'm factoring that one out. Plus cosine squared x. Which leaves us with this right here goes away, because it's just 1. Sine squared x plus cosine squared x, that's a Pythagorean identity. That's 1. That leaves us with sine squared x equals sine squared x, which is true. That one was fun. Oh, I hope I wasn't off the page. I just looked over my monitor. Hopefully I wasn't off the page there. Okay. Ugh. So looking at this, it's subtraction. They are not common denominators. So we either get common denominators or convert to sine and cosine. Let's try to convert to sine and cosine. So secant is 1 over cosine. So this bit right here, we'll just split those fractions. That's going to be 1 over cosine theta times, and then we have this cosine on bottom, not I thought x. We have this cosine on bottom, so that cosine will stay on bottom. Minus, so tangent is like saying sine, sorry, nope, tangent is, yeah, sine over cosine. I'm looking at this now and I'm seeing that I'm doing it the very long way, but that's okay. And then cotangent is going to be, well, cotangent's on bottom, so we can flip it to put on top to be tangent. Or we can just do 1 over cotangent. So 1 over cotangent is let's write as 1 over cotangent. is equal to 1. So this might be this is one where actually turning it to sine and cosine is just a little bit longer. But let's see where it would take us. 1 over cosine squared. 1 over cotangent is tangent, so that would be sine x over cosine x times tangent of x. So at that point, we can now make that sine and cosine 1 over cosine squared theta minus sine x times over cosine x times sine x over cosine x is equal to 1. This ends up being 1 minus sine squared theta over cosine squared. So sine squared, so this is cosine squared, this is cosine squared, common denominators, is equal to 1, and that's true. You can either multiply both sides by cosine, or you can replace this right here. Am I still on the page? Replace that with cosine squared theta, and we are correct. Okay, so this one, secant squared, oh, nope, make sure on the page, lost my pen. Make sure we're on the page here. Secant squared x over cosecant, secant squared x over secant squared x minus 1 is equal to cosecant squared. So we have a lot of good stuff in here. Namely, we have a lot of squares, which means that's going to hint at some Pythagorean identities. I do have a Pythagorean identity with cosecant squared. That Pythagorean identity is 1 plus cotangent squared theta equals cosecant squared. So if I can get this side to somehow equal 1 plus cotangent squared, that would count. Looking at it, I'm not 100% sure how I would do that quite yet. But I could start with difference of squares. Or I have another Pythagorean identity. Secant squared minus 1. One of our Pythagorean identities is, so let's go over here. Like, do I have a Pythagorean identity with secant squared? And I do. It's going to be 1 plus tangent squared theta is equal to secant squared theta. Which means that if I subtracted 1 from both sides, tangent squared theta is equal to secant squared theta minus 1. Check your identity sheet. This right here, secant squared minus 1 is the same as that, so I can replace it with tangent. So that's what I'm going to do. Check for my Pythagorean identities, especially if I have stuff that says minus 1. So this turns into secant squared x over tangent squared x. So now what should we do? Well, bring this other side down. I like this better because it doesn't have the subtraction in it. So let's instead, this is going to be secant. So if we change this into cotangent, get rid of the denominator here, secant squared times cotangent squared I switched to theta instead of x. I apologize. Is equal to cosecant x. So secant is just 1 over cosine squared. Cotangent is just, so cotangent squared should be cosine squared. Again, switch to theta. Over sine squared. I have a cosine on bottom, cosine on top. That is 1 over sine squared x is equal to cosecant squared x. And that's just true. Those are reciprocal identities. And so we're done. That's an interesting thing, because when I saw cosecant squared, I really thought that we were going to end up with this, but we just ended up using the Pythagorean identity here instead, and it did make things easier. Okay, we got one more of these things. This video is already hitting 20 plus minutes. Probably the longest of the 3 videos, or the 6 videos. Okay, so I got tangent squared x times sine squared x is equal to tangent squared x minus sine squared x. That's kind of an interesting pattern there. Multiplying the two together is the same as subtracting the two. Curious and kind of cool. Well, let's see if it's true. Maybe it's not true. Maybe it's a typo. Let's find out. What do I want to do here? I got some subtraction. I got difference of squares right here. I can make this sine. That wouldn't be sine. Where do I want to start? I guess I can try difference of squares, but I don't know where that's going to get me. Let's see. I guess I'll just try something here. So this would be sine squared. Let's change tangent to sine over cosine. Times sine squared x is equal to sine squared over cosine squared minus sine squared x. Okay. Now what? Let's see. So this is going to be sine to the 4th power x over cosine squared x is equal to, if we get common denominators here, let's see, sine squared x over cosine squared x minus sine squared x. Let's, instead of getting common denominators, because that's messy and annoying sometimes, both of these are cosine squared, so I'll just multiply both sides by cosine squared x and just get rid of the denominators everywhere. So those will cancel out, and this would give me sine to the 4th power x is equal to, so that cosine would cancel out, but this would distribute in. So we get sine squared x minus sine squared x cosine squared x. And if we factor out a sine squared from both sides, we would end up with sine squared x times 1 minus, so that'll be 1, right? 1, unless I did something, nope. 1 minus cosine squared x sine to the 4th power x. And then sine squared x right here. Sorry, 1 minus cosine squared is just sine squared. So this would just be sine squared x. So we end up with sine to the 4th power x. Sine squared times sine squared is sine to the 4th power x. And we're done. Cool. Cool. That one took a minute for me to think about and look through, and it's just, again, pick a path and start going. And as long as you're getting simpler with every step, you should finally get there. Okay, that concludes page 4. And I'll see you guys on page 5.